In 2023, a single line of JavaScript code took down half the internet for 3 hours. Why? One developer forgot to validate user input, just once. That tiny slip cost companies millions and hit billions of users worldwide. Every line of JavaScript you write is either a fortress wall protecting your users or an open door for cybercriminals. What's the difference? Knowing the secrets that turn sloppy code into hacker-proof applications.
Welcome to my channel. I've spent over a decade tracking down security flaws in real-world JavaScript apps. Today, I'm giving you the exact strategies I use to write code that hackers hate. This isn't theory. These are battle-tested moves straight from the front lines of cybersecurity. By the end of this video, you'll think like a security expert, code like a pro, and actually sleep at night knowing your app is locked down tight. Ready? Let's dive into the mind of a JavaScript security master and make your code bulletproof. Alright, before we write one line of secure code, you've got to flip your mindset. Most devs write code with fingers crossed, assuming users will play nice, data will be clean, and nothing bad will happen. But here's the truth. Security pros think the opposite. We assume every user is shady, every input is a trap, and every click could be an attack. Sound paranoid? It's not. It's how you survive as a developer today. Think about it. Every second, over 2,200 cyber attacks are hammering away at systems around the world. And JavaScript apps? They're a hacker's favorite snack. User data, payments, logins, all ripe for the taking. Let me tell you about Sarah, a brilliant developer. She built a gorgeous e-commerce site, sleek design, fast pages, smooth checkout, but she missed one thing: security. One tiny XSS hole, just 3 missing lines of code, and within a week, hackers drained her customers' credit cards. The cost? $2.3 million. Lawsuits, angry customers, brand reputation in flames. Don't be Sarah. Be the devs whose code hackers respect because they can't crack it. Ready? Let's build JavaScript apps that are beautiful, fast, and bulletproof. Alright, let's start with cross-site scripting, or XSS, the silent killer of JavaScript apps. On the surface, it looks harmless, but once it's in, it's like digital poison. It can steal passwords, hijack sessions, and basically turn your website into a hacker's playground. Here's how sneaky it is. Say someone posts a comment on your blog. Looks innocent, right? But what if that innocent comment has this inside? Alright, let's see this in action. First, we type some text, hit submit, check the page with inspect element. Looks fine, right? Now, watch what happens when we sneak in a little script. Boom. Just like that, every visitor gets hijacked. The attacker snatches session cookies, impersonates users, and walks right into their accounts, all because we trusted user input. Big mistake. That's how security pros handle this. Sanitize everything. Or if you really need HTML, run it through a sanitizer like DOM Purify. See what just happened? That evil script turns into harmless text. Your user sees their comment, but the browser doesn't run any dangerous code. Simple, solid, safe. Never, ever use inner HTML with raw user data. Use text content for plain text or sanitize it properly if you really need fancy formatting. This one habit kills 90% of XSS attacks before they even start. Protect your site, protect your users, and make hackers hate your code. Ready for the next vulnerability? Let's lock it down. XSS is digital poison. Injection attacks are Trojan horses. They hide malicious commands inside legitimate-looking data, tricking your application into executing code you never intended. Here's a classic mistake I see in Node.js applications. Right, let's check out a simple login form in a normal, happy scenario. You enter a valid username and password, submit the form, and watch the request. All good, right? Looks totally normal. But here's where it gets interesting. Watch what happens when an attacker sends this instead. Suddenly, your entire user database is gone, deleted, vanished. The attacker didn't hack your server, they tricked your own code into destroying your data. So how do the pros shut this down? Simple. They validate everything with things like regex to make sure input looks exactly how it should. And even better, they use parameterized queries. That means the database treats your input as plain data, not executable commands. Result? The attack bounces right off. Your database stays safe, your user stays safe, everyone's happy except the hacker. Authentication and session hijacking. Think of authentication like the front door of your entire application. If you mess it up, you've basically handed the keys to your kingdom to anyone sneaky enough to stroll right in. Let's make it real. Imagine you just built a shiny new banking app. A user logs in from a cozy coffee shop, checks their balance, then packs up and leaves. All good, right? But here's what they don't see. Their session token is now drifting through the network in plain text, wide open for any hacker with a packet sniffer to grab, reuse, and break right into their account. One tiny security gap and your secure app isn't so secure anymore. Right, here's a quick demo of how session hijacking actually happens. Check out this code. It's got more holes than Swiss cheese. We're talking weak session tokens, no HTTPS, no token expiration, no secure flags. Basically, it's every hacker's dream setup just waiting to be exploited. Here's how real security experts lock down authentication. Look at all these layers we've added. Rate limiting to shut down brute force attacks, strong password hashing to protect what's stored, cryptographically secure tokens that can't be guessed, secure cookie flags to block sneaky hijacking tricks. This isn't just code, this is digital armor. Every line does a job, every layer shuts down a different attack path. This is how you build authentication that hackers respect and can't break.
All right, now we're stepping into advanced territory, where real security pros stand apart from amateur coders. We're talking about things like content security policy and smart security headers that turn your app into a fortress. Think of CSP, content security policy, like a bouncer at every door of your site. It tells the browser exactly what's allowed to load and run, and blocks anything suspicious trying to sneak in. No unexpected scripts, no shady requests. Just your code, your rules. It's one of the best ways to slam the door on sneaky attacks like XSS.
Break down the security armor piece by piece. Access content security policy blocks shady scripts and unauthorized resources. HSTS forces every connection to use HTTPS, no exceptions, for a whole year. X-frame options stops attackers from loading your site and a sneaky iframe to pull off clickjacking. X-content type options prevents browsers from guessing file types, shutting down MIME type confusion tricks. Referee policy controls exactly what info your site shares with other sites. Permissions policy locks down sensitive browser features like the camera, mic, or geolocation. So when hackers try to sneak in scripts, load junk from shady domains, or trick users with fake frames, these headers slam the door in their face. It's like stacking security gates. Each layer catches attacks before they ever hit your real app. Break down your must-do security checklist. Input handling. Validate all input everywhere. Double-check user input on the client side for speed, but always validate it again on the server where it really counts. Sanitize your data before showing it. Use tools like DOM Purify to clean any user-generated content so no hidden scripts can run. Use text content, not inner HTML. If you're just showing plain text, don't use inner HTML. Text content makes sure the browser treats it as text, not executable code. Use parameterized queries for databases. Always run database queries with parameters, not string concatenation. This blocks sneaky SQL injection tricks. Key hash those passwords. Store passwords using strong hashing algorithms like bcrypt, so even if someone breaks in, they can't read them. Use secure session tokens. Session tokens should be random and cryptographically strong, not easy to guess. Secure your cookies. Always use secure and HTTP-only flags for cookies and set proper expiration so they can't be stolen or abused. Stop brute force attacks. Add rate limiting on login attempts so hackers can't just keep guessing passwords forever. HTTPS everywhere. No excuses. Always use HTTPS to keep traffic encrypted from user to server. Never trust just the client. Even if you check stuff in JavaScript, you must verify it again on the server, because clients can be tampered with. Authenticate and authorize every request. Check who's making the request and if they're allowed to do what they're asking. Don't leak secrets in error messages. Use proper error handling. Never show detailed errors to the user that could help attackers. Control cross-origin requests. Set up CORS policy so only trusted sites can talk to your backend. Add content security policy. A CSP header tells browsers what's allowed to run, blocking unauthorized scripts by default. Use extra security headers like HSST, X-frame options, and X-content type options. They add extra layers of defense against common attacks. Run security audits and update. Keep your dependencies up to date and run regular security checks to catch new vulnerabilities. Log and monitor security events. Keep an eye on suspicious activity. Logging and monitoring help you detect attacks early and respond fast. Put this all together and you're not just writing code, you're building a fortress your users can trust.
The truth. Security isn't a finish line. It's a journey. Every single day, new bugs pop up, new attack tricks appear, and what you thought was safe last year might not cut it today. The developers who thrive, they stay curious, they keep learning, and they never stop leveling up their skills. If this video helped you see JavaScript security in a whole new light, go ahead and hit that subscribe button and join thousands of other devs who want to write bulletproof code. Every week, I break down the latest security techniques, dive into real-world hacks, and share practical tips you can use right now. Drop a comment below. Tell me which vulnerability shocked you the most, or share your own oops moment so we can all learn together. This community learns together, grows together, and makes the internet safer together. And always remember, every secure line of code you write makes the digital world just a bit safer. You're not just a developer. You're a guardian of user trust, a defender of digital privacy, and a builder of the secure internet we all deserve. I'll see you in the next one. Stay curious, stay secure.